Let us talk about skewness today. So what do you mean by skewness? So skewness is measuring the symmetry, or more precisely, the lack of symmetry in the distribution, right? So, and when do you say that the distribution is symmetric? When the values on the left and right, they are looking exactly like each other, right? Around the center point. So skewness measures, please write. The symmetry. Guys, I urge you to make notes side by side, right? Then only you will understand it better. Or more precisely, the lack of symmetry. So around the center point, in case of the distribution looks exactly equal, right? Or exactly same around the center point, that means that distribution is symmetric. A distribution is symmetric if it looks same to the left and right of the center point. Right, right. So normal distribution is helping us to know the skewness of the distribution. I mean, we can compare it. I mean, any distribution to the normal distribution. So normal distribution is a very symmetrical distribution, right? So its mean, median, mode are going to coincide and the skewness is going to be zero. So 50% of the 50% of the values will be to the left of the central point, and this 50% of the values will be to the right of the central point, right? So when you have a normal distribution like this, the normal distribution helps us to know the skewness. So in normal distribution, your mean, median, mode, they are going to coincide, and 50% of the values will be to the left of the central point, and 50% of the values will be to the to the right of the central point. So you have a curve like this, right? So you guys have a curve like this, and something this way. And here, your mean, median, mode, they are coinciding with each other. So 50% of the values to the left, 50% of the values to the right, right? So this is a very symmetrical distribution. This is a very symmetrical distribution. Well, you can have a case of asymmetric distribution. So asymmetric distribution can be positively skewed, or asymmetric distribution can be negatively skewed. Asymmetric distribution. Well, it can be of two kinds. Positively skewed. Or negatively skewed distribution, right? Negatively skewed distribution. So let's have a look at that. So what do you call as a positively skewed distribution and a negatively skewed distribution, right? So when we say positively skewed or negatively skewed, so we have to think it like this. So when the tail of the distribution is more towards the right of the what do you call the center of the distribution, more towards the right of the center of the distribution, you call that as the positively skewed distribution, while the negatively skewed distribution is when the tail is more towards the left of the distribution, right? So how do you write this? So we have like this. So can I just put it some space here? Just wait. So you have a distribution like this, right? And you have a distribution like this. Like this. So as you guys could see, the tail is more towards the right side of the distribution. That is, the tail towards the right side of the distribution is longer or flatter, right? So you can just write it this way, that the tail towards the right side of the distribution is longer or flatter. Okay, I'll tell you something more about that. Just let me just draw the negatively skewed distribution. So negatively skewed distribution is when the tail towards the left side of the distribution is longer or flatter. So it is somewhat like this, somewhat like this. That is tail towards the left side is of the distribution is longer or flatter, right? Here is going to be the mode of the distribution. This peak. Right. Now, median is going to, I mean, the 50% of the distribution will be somewhere here. So I'll use the another color so that you remember. This one. This is median of the distribution, right? 50% of the distribution, somewhat. Let's say this is 50% of the distribution. And here, this is going to be the mean of the distribution. right? So for the positively skewed distribution, you guys could see that the mean is greater than mode and median, while for the negatively skewed distribution, your mean and median are going to be less than the mode, right? So here mean is greater than median is greater than mode. Here mean is less than median is less than mode, like this, right? So this is about the two different kinds of asymmetric distribution. Now let us connect the meaning of this skewness with the movements. So we have been talking about movements for quite some time. So let us connect this with that. So suppose we have n values. X1, X2, and so on to Xn. And you take the deviations. X1 minus X bar, X2 minus X bar, and Xn minus X bar, right? You take deviations from arithmetic means such that corresponding to every positive deviation, there is a negative deviation. So when you sum them up, they cancel out each other, such that corresponding to every positive deviation, there is a negative deviation of the same magnitude. If this is there, the same magnitude, then we have a symmetric distribution of X about X bar, right? And in this case, if you take the central movement, the third central movement, like this. So if you take, in such a case, if you take the central movement, third central movement, so it will look like this. So I hope you understood this symmetric distribution, because the deviations are canceling out each other. So this is a symmetric distribution. And in case if you take the symmetric distribution, if you take the third central movement around, of course, this is central movement, so it means it is around mean. This is also going to be equal to 0, right? Because when the deviations are raised to the power of 3, then the positive deviations are going to cancel out the negative deviations in the sum. Because deviations raised to the power of 3, right? So positive and negative deviations in the summation will balance out. Will balance and cancel out, right? So a symmetric distribution will be looking like this. Something like this. A symmetric distribution will be looking like this, right? But supposedly, if the positive and the negative deviations, they are not canceling out each other, then you have the asymmetric distribution. So it could be positively skewed, or it could be negatively skewed, or skewed distribution. So please write if the positive and negative deviations do not balance, we have the situation of symmetric asymmetric or skewed distribution or skewed distribution. So we are looking at this way that this mu3 is the measure of the skewness, right? But it is generally not accepted as a measure of skewness because the problem with mu3 is that it is not free of the units of measurement. It is not free of the units of measurement, right? So if whatever is the unit of measurement of x, that is going to be the unit of measurement of mu3, because that is going to be x cubed. So whatever. So for example, if it is centimeters, so the unit of measurement for mu3 is going to be centimeter cube, like that. So other thing is that this mu3 is not accepted as a measure of skewness because it is not free of the units of measurement. So the units of measurement of mu3 is going to be whatever the units of measurement of x to the power 3, right? That is going to be the units of measurement. So if you want a scale-free measure, which is free of the units of measurement, so what you do is that you divide this mu3 by sigma cube, right? So you define the another measure, which is called root of beta 1, which is mu3 upon sigma cube. Mu3 upon sigma cube. So mu3 will be the units of measurement of mu3 is going to be what? Your whatever is the units of xi to the power 3. Similarly, the measurement for this guy, the units of measurement for sigma cube will also be the units of measurement of xi to the power 3. So that is going to get cancelled out and you will have a scale-free measure, right? So it is free of the units of measurement. So this is basically taken up as the measure of skewness. So it is free of units of measurement. And it is a pure number. Right. So you can write that if root of beta 1 is equal to 0, what you write is, and when is root of beta 1 is going to be 0? When mu3 is going to be 0. So when mu3 is going to be 0, you have seen that the distribution is symmetric. So distribution is going to be symmetric, right? If root of beta 1 is going to be greater than 0, when is root of beta 1 going to be greater than 0? When mu3 is going to be greater than 0, right? So when mu3 is going to be greater than 0, then the distribution is going to be positively skewed. And when is root of beta 1 going to be less than 0? When mu3 is less than 0. So in that case, the distribution is going to be negatively skewed. So this is when mu3 is equal to 0. This is when mu3 is greater than 0. This is when mu3 is less than 0. So I'll have something more to talk about the skewness in the next class, right? Thank you, Beta.